Alright, so this is a test of the linear actuated elbow, so if you want to flip it on. Right now it's going in reverse, so okay, so turn it on. So essentially what's happening is H-bridge is amplifying the 5-volt signal from here and turning it into 12 volts, which is then powering this actuator, which requires 12 volts. So there's two inputs. If you power input 1, it moves down. If you power input 2, it moves up. So I'm going to power input 2 right now, and in the future we'll use an Arduino that will interact with the Hall effect sensor to move it up and down accordingly. Yeah.
Thanks, yeah, that's good. So here we've got the hip rotation set up onto the unpowered armature. So we did this because we didn't want the wearer of the exoskeleton to be confined to walking in one direction at all times. So this will hopefully allow them to rotate and turn so they can change directions. So next week we'll be testing it out 100% complete, putting all the other pieces on and tying it to someone to see if it actually allows them to change directions. In terms of the hip piece here, we've got a piston that's anchoring, hold on, there we go. A piston that's anchoring from here down to like kind of the midpoint of the whole leg, so like the bottom of the thigh piece. And then we're trying to figure out a good way to make the knee pretty compact.
Right now we're programming for this board an AT-Tiny that detects 2 Hall effect sensors, so that we can go up and down with the arm, and also can control this H-bridge right here.
Connor, what are you working on?
What?
Okay, so right now we're making the braces for our frame that's going to hold the exosuit, so we can display it and so we can practice in it without having the risk of falling over. These braces are going to be used to connect the entire frame together so that we can fold it up flat when we're done. Connor, it's way too short.
There's one. Oh no, that one's perfect! Oh my god, Connor, you're beautiful.
I am beautiful.
Exactly.
So if this was executed, this isn't true.
Yes. This version of the arm uses an array of Hall effect sensors instead of a single Hall effect sensor like the previous prototype does. It allows us to bring a magnet close to either one of them to bring the arm up or down.
Then we're talking about 300 or 400 pounds total. Because you got
And I think
a
for
fairly
sure
light
this.
load plus the suit plus you.
Okay, so right now what we're doing is we're constructing models for a stand to support the exosuit from. So here we have a triangular base where the weight is distributed out, and then we have a more classic design, which is just a cube.
Yeah, 4 feet.
So 4 feet?
Yeah, so 4 foot base.
You guys can all do this motion?
Yeah.
Okay, good.
I can move my legs, yes.
Conveniently folds for packing.
Right now we're testing this valve manifold to see if our proof of concept actually works. It should shoot air out of this hole, then it should shoot it out of both holes, and then just this one, as Connor slides the potentiometer back and forth. So connect it. Got this one. Try to get it so that both of them are
So here we've got one of the joints hooked up for the leg prototype. So what's happening is the compressor is feeding in a line of air into this valve manifold, and then that opens and closes when told by this control board here, which was made by Cole and Gabriel, and this reads the output from the slide potentiometer. So when I move it back and forth, it will send the air to the designated valves like this.